Okay, so this is Gauss-Jordan elimination, and this is very similar to Gaussian elimination, but with extra steps. And it's not a big deal if you can't stay the whole time because these are recorded, so you can see whatever you missed. So this is just a review, and for anybody who watches the recordings but maybe doesn't watch every video. So so matrix is how we write equations without variables. It only works for linear equations though. So you can do matrices with other types of equations, but generally they all have to be sort of the same type of equation, because we've done matrices, well, you haven't, but I've done matrices with things that are like derivatives, which is something from calculus. But most of the time it's linear equations, and it allows us to kind of condense our work, and we only have to worry about the numbers. So when you put it in its matrix form, that's called the augmented matrix. And if you ignore the constants that it's equal to, you get just the coefficient matrix. So each item is an entry or an element. I usually refer to them as elements. The dimensions are always row times column. And if the rows are equal to the number of columns, it's square, otherwise it's rectangular. The diagonal always starts at the upper left corner and then goes diagonally down. A row matrix is just a single row. A column matrix is just a single column. So just some vocabulary. Our row operations are you can interchange rows. You can multiply a row by a constant, non-zero, because otherwise you're just turning it to zero. And you can add rows to each other and then replace another row. And so this is what we're doing with solving. So here's where we get into the difference between Gaussian elimination and Gauss-Jordan elimination. It's the difference of the final form. So we have row echelon form, which is what we were doing with Gaussian elimination. And the abbreviation is REF. There's also reduced row echelon form, where you have the ones in the diagonal, but everything above a 1 has to be 0. And so that's abbreviated with REF. So you do want to be able to, understand the difference between those two. Because that's the difference between Gaussian elimination and Gauss-Jordan elimination. You're still doing the same steps. Gaussian elimination, you get to a point where you stop and then you back substitute into the equations. If you keep going and try to get zeros above the ones, then you're getting the reduced row echelon form, and that's Gauss-Jordan elimination. And then you don't need to do any back substitution at all because your answers are in the last column. So whether you prefer one or the other is just personal preference. Some people prefer to do Gaussian elimination and then do the back substitution. Some people like to do Gauss-Jordan elimination and then they don't have to do any of that and they just look at their answers in the last column. So it's really personal preference because you will get the same answer either way. So the one thing that's going to be really key is being able to check your work because as I discovered, I can make math errors. So there is this website, Octave Online. So I'm going to just open it up and kind of show you how to use it. And it does a lot of math stuff, but you do have to kind of know the programming language it uses, which is basically, it's based off of MATLAB, but it's pretty easy to learn for matrices. So I have an example right here. So when you enter in a matrix, you do it row by row, and there's semicolons or semicolons between each row. and then a space between each number. And you can verify that you entered it correctly, because after you hit enter, it will display, and that gets typed right down here. And then if you want to do the Gauss-Jordan elimination and you're checking your answer, you just type in RREF. That's that abbreviation I gave for the reduced row echelon form, and then you put your matrix that you, whatever you named it, you put that in parentheses and it'll give you the answer. But it does give it to you in decimal form. So if it's something that's fractions, you will still have to, you can't use this to solve because we want fraction form, but you can use it to check your answer. So I recommend maybe bookmarking this and using it. It's not that hard to use just for the matrix parts. It will be very handy, especially if you are going into electrical engineering technology or any of the engineering classes, because you do end up solving a lot of systems and using matrices, and this will just make your life so much easier. So I would just want to, we will check our answers with this, so you'll see it in action, but I just wanted to kind of show you that so you can bookmark it. So it's just octave-online.net. And MATLAB is a very well-known math programming language. It's very powerful, and it's nice to have a free version. So we're going to do these by hand, and then we'll check our answers. So we're doing specifically Gauss-Jordan elimination. So I've got on the right that our goal is we basically want the identity matrix on the left, and then our answers are going to be that last column. So the first thing we need to do is actually write the augmented matrix. And it's really important to know the vocabulary because, oops, I was about to write the word vocabulary. You want to know the vocabulary because on the homework, I believe one of the problems does specifically ask for the augmented matrix, and I'm usually given the wrong thing. So it's really important to know what's being asked. So it's just the coefficients. So we've got 5, -5, -5, and then -2, -3, and 7. And then if you want, you can put kind of a dashed line to separate where you want your identity matrix from the answers. So I always first try to get the bottom to be 0. So I need to get that -2, that bottom left corner, to be 0. And so I like to write this out. So I need to get, let's see, so the first column, I've got a 5 and a -2. So in order for those to cancel out, I have to get it to 10 and -10 because that's the least common multiple. So we basically have to multiply the top by -2. So -2 times row 1 plus, and then the bottom has to get multiplied by 5 to get to, actually I don't need a -2, just a +2, row 1 plus 5 times row 2. So that will give me a 10 in the upper left corner and then a -10 in the lower left corner. And then I'm going to take whatever that answer is and replace it in row 2. Now, it's very easy to make mistakes while you're doing this, so I will write the math separately because I find if I try to do it in my head, I'm going to make a mistake. So 2 times row 1. So I just multiply that first row by 2. So that's going to be 10, -10, -10. 5 times row 2, -10, -15, 35. And then I'm going to add those together. 0, -25, and 25. And now I'm going to rewrite my matrix. 5, -5, -5, 0, negative 25, 25. And if you find any math errors, let me know. Because, like I said, it's very easy to make a math error here. So now I've got my 0 on the bottom left. And the next thing I want to do is get the 1 in the second column for second row. That negative 25 needs to become a 1. So I basically need to divide row 2 by negative 25 to get that to be a 1. So row 2 divided by negative 25, and I'm going to replace row 2 with that. So you could also write this as multiplying by a negative 1 over 25. And that's how I was taught to write it, but it means the same thing. So it's kind of easier to think about it as dividing it by negative 25. And that's easy enough to do in your head because you're not combining rows. So the first row is staying the same. Negative 25 divided by negative 25 is 1. 25 divided by negative 25 is negative 1. So now we've got my 0 and my 1. And now the next thing that I work on is the first row to get the 1 and the 0. And honestly, you don't have to do it in this order. This is just the order that I tend to do. You know, this is just the order that I do. But if you wanted to, and it actually probably would have been easier, but we could get the 1 in the upper left corner first and then do the rest of it. And that probably is easier to do it that way. But, you know, that was not the way that my brain was thinking when I looked at this. So, but we do have to get a 1 in that upper left corner. So that's just going to be dividing that first row by 5. So I'm going to do this on my next slide. So we're going to take row 1, dividing by 5, and then replacing that in row 1. So that gives us 1, and then we're going to get a negative 1, negative 1, and we have 0, 1, negative 1. And here, this is where you would stop if you were doing Gaussian elimination. So this is row echelon form. But we are doing Gauss-Jordan elimination, so we are not done because we want to get that negative 1 to be a 0. Because above every 1, we want to have a 0. So in order to do that, I need to add essentially row 1 and 2 together, and that will, because I've got a negative 1 and a 1, those will cancel out, and then I can replace that in row 1. So I'm taking row 1 plus row 2, and then I'm putting that in row 1. So again, I just write my stuff separately so I can make sure that I do this right. So row 1, row 2, and when you add it, you get 1. Oops, it'd help if I copied down the row correctly. Negative 1 plus 1 is 0. Negative 1 plus negative 1 is negative 2. And so now row 1 is going to be 1, 0, negative 2. We have 0, 1, negative 1. And now that we've got our identity matrix, we've got the ones in the diagonal, zeros elsewhere. This is reduced row echelon form. So in this case, it was only one extra step. And it was a pretty easy step. Otherwise, you'd have to write your equations and back substitute. But here we only had to do one more step, and now we have our answers. We have -2 and -1, and it's in the order of x and y. So Our answers are that x is -2 and y is -1, or as ordered pairs, -2, -1. And you just literally read that off from your last column. Those are your answers. So I personally prefer reduced row echelon form because I prefer doing that than trying to write my equations and then back substitute. I think it's easier, but you do get the same answer either way. And now I'm going to bring up the Octave to show you how you can, check your answer here. So we're writing our answer in this little, or our matrix here. You can call it whatever you want. You can call it A, B, C, example 1. Like I can literally just type example 1, whatever you want to call it. Put in a bracket because our matrices have brackets. And then I'm going to type in my matrix that I had formed right here. 5 space -5 space -5, and then a semicolon. And then -2 space -3 space 7. And then I close my bracket and I hit enter. And then we're doing reduced row echelon form. So I do R, R, E, F, and then in parentheses, whatever I called my matrix. So I called it example 1. So I just type that in, and then we got the same answer that we did by hand. We have -2, -1 as our two answers. So checked our work. There's no math errors. We got the same answer. There are questions on this example? Okay. You like the Octave website? Yeah, it's really nice for checking your work. So I do recommend playing around with it. Okay, so let's do 3 variables, 3 equations. We're going to use the Gauss-Jordan elimination here. So I've got 2, -1, 3, and then 24. I've got no x terms, so that's going to be 0. 2, -1, 14. And then we've got a 7x minus 5y, no z term. Bad looking 7. And then that equals 6. Okay, so this is our augmented matrix, and we need to get basically the identity matrix in our left. And I've already got one of the zeros where I need it to be. And I have a 0 here where I don't need it to be. So if I just highlight what I have this 0, so that's in a good place. And then this 0, we want a 1 down there, not a 0. We want the 0 elsewhere. So first thing I would do would be to interchange rows 1 and 3 so that I can have that 0 in the right spot. So row 1 and row 3. We'll switch directions so we can make sure that we have that 0 where we want it to be. So we've got 7, -5, 0, 6, 0, 2, -1, 14, and then 2, -1, 3, 24. And so now We've got at least 2 zeros in the correct places from where we need them to be. Now, in the last example, I mentioned that I could take that first row and make that first number, the first element, 1. If I do that here, I would have to divide everything by 7, and then I'm going to have some nasty fractions, and I don't really want to work with fractions right now. So I'm going to kind of save that to the end because I want to try to avoid having fractions as much as possible. Because if I'm going to divide by 7, I'm going to get a negative 5 over 7, a 6 over 7. It's just going to be a lot harder for me to work with. So I'm not going to try to get my ones right away. I'm going to get my zeros because I just find that easier and it avoids kind of these fractions. So the first thing I'm going to do is, again, get that bottom left corner to be a 0. So I've got a 7 and a 2, so I need to make those 14 and negative 14. So I'm just going to kind of work on the right since I've got some space here. So I'll take a negative 2 and multiply it by row 1. And then I'll just take a 7 and multiply it by row 2 or row 3. And then let's replace that in row 3. So it doesn't matter which one's negative. I could do a positive 2 and a negative 7, but I'm going to do those so I can get that 0 in the bottom left corner. So negative 2 row 1 would give me negative 14, 10, 0, negative 12. And then 7 times row 3 would be 14, negative 7. 7 times 3 is 21. And I definitely needed my calculator for 24 times 7. That's 168. So I'm going to combine these. Negative 14 plus 14 is 0. 10 minus 7 is 3. 0 plus 21 is 21, and then 168 minus 12, 156. So now my matrix is 5, negative 7, 0, 6, 0, 2, negative 1, 14. And then we just got 0, 3, 21, 156. So if it helps you, you can like highlight all the parts that we have that are what we want them to be, just to kind of help you keep track. So now I've got my zeros in the first column, and I want to get some zeros in the second column. And I noticed that last row, I've got 321. I can divide those both by 3. So I just put in my calculator 156 divided by 3, and that does come out evenly. So I'm actually going to get a 1. I'm going to take that third row divided by 3 and get a 1 there, and then I'm going to interchange it with my second row. So that way I can put my 1 where I need it, because that will be a lot easier than try to get that 3 to a 0, because it's so easy to make it a 1. So you have to kind of, while you're doing this, you know, you're working with these matrices, you're kind of looking ahead, looking at your options and seeing what's the easiest thing to do. So I'm going to divide row 3 by 3 so I can get a 1 there. So row 3 divided by 3. And I'm just going to put that in row 3 for now. I'm not going to do the interchange at the same time. Yes, you can swap rows whenever you want. Whenever it's convenient for you, you can swap rows. That's the nice thing, is you can do these in any order. So, you know, if you find out you have things in the wrong order, you can swap rows again. So let's see. So we've got 7, negative 5, 0, 6. Then we had 0, 2. It's a lot easier when you have it on one sheet of paper. Negative 1 and 14. And then I have 0, divided by 3, so that's going to be 1. 21 divided by 3 is 7. And then the 156 divided by 3 gave me 52. And so you can see that now I've got that 1, it's just in the wrong spot. So we can do row 2 and row 3, interchange those, so I can put the 1 where I want it. So I've got 7, -5, 0, 6, 0, 1, 7, 52, 0, 2, -1, 14. And so if I highlight what we've got correct so far, we've got our zeros, and now I've got a 1, but I still need to make that 2 to be a 0, and then I'm going to have to get that -1 to be a 1, and then I have to make the 7 a 0, -5 a 0. We've still got a ways to go. But it's pretty easy to make that 2 to be a 0, because all I need to do is multiply the second row by -2, add them, and then replace that third row. It's just a matter of making sure that everything is organized, and that's the hardest part here, is organizing it all. So I'm going to take the second row multiplied by -2 and add that to the third row, and then replace the third row with the result, because that will get me a 0 there. So just to make sure I do all my math correctly, I like to, do the multiplication separately. So if I multiply the second row by -2, I get a 0, -2, -14, and then 52 times -2 is a -104. Then I'm adding that to row 3, which is 0, 2, -1, 14. So I add those together, it's 0, 0, -15, and then -90. So my result is 7, -5, 0, 6, because I didn't touch row 1. I haven't replaced row 2, so that's still going to be the same. And now row 3 is going to be 0, 0, -15, -90. And so now we're getting there. We're getting to where we want. We've got partially it there. We're the next thing that I looked at, I look at this and I'm like, oh, row 3, I've got a -15 and a -90. I know that I can divide 90 by 15. So we can make that bottom row have that 1 really easily. All we need to do is divide row 3 by -15. So I'm going to try to squeeze it in. I'm going to do row 3 divided by -15 and try to squeeze it on this slide so I don't have to move to another slide. So I've got 7, -5, 0, 6, 0, 1, 7, 52, 0, 0, 1, and then -90 divided by -15 comes out to 6. Now, I don't recommend kind of zigzagging the way that I am here. I recommend just working entirely vertical. I'm only doing it this way because I've got a limited amount of space and I'm trying to fill up the space that I have. So now I'm almost there. I've got to get the -5 to be a 0. I've got to get the 7 to be a 0. And then I have to get that 7 to be a 1. But I'm going to do that 7 as a 1 last, just because I know if I do it right now, I'm still going to have to deal with those fractions, and I want to avoid the fractions. So first thing, when you're working with a 3 variable one like this, if I get the -5 to be a 0, now I would have to use row 2, but then that's going to take the 0 that I have in row 1 and replace it with a number, because I'd be adding that 7 to it, or it would be 35. And so that would undo that 0 that I've already got in the right place. So what I really should do is take the last row and get that 7 to be 0 first, and then work on getting the -5 to be a 0, because that will be more efficient. You won't have to do as much work, because I won't be putting a number where I have a 0 that I already want. So we're going to take row 3 and multiply it by a -7 so that I can cancel it out with 7 in row 2 and get a 0 in that location. So we're taking -7 times row 3, adding it to row 2, and then I'm going to replace row 2 with the result. So -7 row 3 is a 0. I have 1 times -7, and then I add a 6. 6 times -7 is -42. Row 2, we have a 0, a 7, and then 52. Oops, I'm missing my 1. Oops, I missed a whole column. I will just stick that right here. 0, 1. I missed a whole column. Okay. No, I put the 1 in the wrong spot. Okay. Actually, these are not matrix form because I'm just adding these. So I'm going to combine these together. I have 0, 1, 0, and then -42 plus 52 is going to give me a 10. So now my matrix is 7, -5, 0, 6. This is my new row 2, 0, 1, 0, 10. And then my row 3 is 0, 0, 1, 6. So we are almost in our reduced row echelon form. Now I want to get rid of that -5. And we will do that by taking row 2 and multiplying it by 5, and then combining that with row 1. So 5 times row 2 plus row 1, and then the result is going to be in row 1. And you don't have to write it in the order that I do. You can write it as row 1 plus 5, row 2. It doesn't matter. So 5 times row 2 is going to be 0, 5, 0, 50. Row 1 gets us 7, -5, 0, 6. So now when I add these, I've got 7, 0, 0, 56. And now I'm going to replace that in row 1. So I have 7, 0, 0, 56. Then row 2 is 0, 1, 0, 10. And then row 3 is 0, 0, 1, 6. And so now we are almost in reduced row echelon form. The only thing we need to do left is take that 7 and make it a 1. And so now we're going to divide everything by 7. and it's going to come out evenly. So I could have done that first, but I waited because it was going to give me fractions. And so I recommend looking ahead like that. You know, if you're going to start creating fractions, don't do that step. Save it. Try to get something else. You know, try to get rid of some zeros. Try to get some other things. So that way you're not working with nasty numbers. So our last step is just to take the first row and divide it by 7. And then that will get us our 1. So we want row 1 divided by 7, and then that result's going to stay in row 1. So that will give us 1, 0, 0, 8, 0, 1, 0, 10, 0, 0, 1, 6. And so now we've got that identity matrix on the left, and so we have our answers. We have x is equal to 8, y is equal to 10, and z is equal to 6. And so when you write it as an ordered pair, you've got 8, 10, 6, because it goes in alphabetical order. And so we can go back to Octave to check our answers. And I'll just reconnect, not a big deal. I want to put in my original matrix. So I don't want to put in, you know, one of the ones that I've been messing with because I might have made a mistake there. So I want to go back to my first augmented matrix, and that's what you want to enter in. And, you know, you can name it whatever. A is super easy. I've got 2, -1, 3, 24, semicolon for the next row, 0, 2, -1, 14, semicolon, third row, 7, -5, 0, 6. Then close my brackets. And then we're going to do reduced row echelon form of A. And you can see we have 8, 10, 6. We go back. We had the same answers, 8, 10, and 6. So we've just double checked our results and made sure that we didn't make any mistakes. Are there any questions on this example? Yeah, practice. It takes time. It is a lot of steps. And that's why I do encourage you to use technology. And so on the application assignment, it's okay to use technology. Just make sure that you give me your original augmented matrix. Make sure you tell me what command you're using, and then make sure you give me your final matrix, and then give me your answers for X, Y, Z, or you know, in a sentence, because these are word problems. So it's totally fine to use technology on the application assignment. Just make sure you're telling me what you're typing in so I know what you did. And you can consider that your work for that. And then make sure you put it in a word, you know, in a sentence. So I've got one more, and I wanted to do one that has multiple solutions, so you can kind of see what this would look like if it's Gauss-Jordan elimination versus Gaussian elimination, just so you can kind of see the difference. So we know that this is going to have multiple solutions because we've got fewer equations than variables. We've got 2 equations, 3 variables, so we don't have enough information to get a solution. So all we have is, you know, we're going to just get some information. So I'm going to put this in matrix form. I've got 1, 1, 4, 5, and then 2, 1, -1, 9. So we've got a 1 in our upper left corner already, which is awesome because, you know, that's what we want. And so now we need to get a 0 in that lower left corner. And so we can do that by multiplying the first row by -2 and then adding it to the second row. So -2 times row 1 plus row 2, and then I'm going to replace that with row 2. -2 row 1 is going to be -2, -2, -8, -10. And then row 2 is 2, 1, -1, 9. And when we combine those, we get 0, -1, -9, -1. So my matrix is 1, 1, 4, 5, 0, -1, -9, -1. So we've got our 0 and a 1 in the right spot so far. Now, if you're wondering, well, what is this going to look like in, you know, row echelon, reduced row echelon form, because we don't really have a 3 by, you know, we don't have 3 equations. We have to get a 0 here, here, and here, because it's just basically you've got your 1 in the diagonal and then everything else is 0. So we've got 3 numbers here that we have to get to be 0. The 1, the 4, and the -9 in order for it to be reduced row echelon form. So I can add my equations together as they are right now, and I can get a 0 right above the -1 because those are already opposite signs. So that's pretty nice. So we are going to just add row 1 plus row 2, and then that result is going to be in row 1 because that will get me my 0. So when I add them together, I can even just kind of use my work here. That's going to be 1, 0, 5, and 4. So that's going to be our new first row. So I've got 1, 0, 5, 4, 0, -1, -9, -1. My slide just kind of closed on me randomly. Let me try. I don't know why it did that. All right, let's try this again. So what I was trying to do was highlight. So oh no, it did it again. What is going on? Okay, this is very strange. I've had this happen occasionally, and it seems to fix itself when I close and open the presentation. So we shall try that. Okay, let's see. So we've got correct spots so far is we've got the 1, the 0, and then we've got a 0, and then we need to get that -1 to be a 1, and then basically we'd be getting 0s in the 5 and the -9 spot if we can, you know, if it's possible, because we shall see as we start doing things. So we need to take row 2 and divide it by -1 so we can get that 1 right there. So row 2 is divided by -1, and then I'm going to replace that in row 2. So row 1 is 1, 0, 5, 4. And row 2 is now going to be 0, 1, 9, 1. So what we've got so far is we do have an identity matrix, but it's not our full reduced row echelon form because we still have this 5 and this 9 here. So the full reduced row echelon form would have those as zeros, because if you were to finish, you know, if we had a third equation, you would have a 0, a 0, and then a 1 right there, and then it would be zeros all above there. So we have to kind of say, well, can we get that? So if I want to get those to be 0, I basically need to have them cancel out. But the problem is, if I took one of the, like, let's say I took row 1 and I multiplied it by a -9, and then I took row 2, multiplied it by 5, so that those are 45, so I can add those and get to 0. When I combine them, I'm going to start putting numbers back where I have my zeros. And that's just not going to work, you know, because now I'm going to have numbers at my zeros, and I'm going to have to work to get those zeros again. So it's just going to be more steps. So we can do it, and let's just do one of these to kind of show you what I mean. So let's see. The problem is, if I get them to be 0, oh, it's doing it again. It just closed itself. So bizarre. Okay, so this must be my sign that it's saying, okay, this is time to end. So what we will do is, because my PowerPoint does not kind of want to go, we will stop here and we will say we are as close to the reduced row echelon form as we can get, because we do have that identity matrix. We just have this extra column here. Now these are generally in linear algebra, this is called, this third column where you've got these extras is called a free variable. So that third column is a free variable where you basically can, you know, replace it with any numbers. So these, you have numbers there. So that's free variable because you've got numbers. So what we're going to do is we're going to just write our equations here. So we've got, this is x plus 5z equals 4. And then we've got y plus 9z equals 1. And when you have infinite solutions, you want to have them solve for x, y, and z. So this is going to be x equals 4 minus 5z. Y is equal to 1 minus 9z. And then when we write our answers in the ordered pair, where it's like x comma y comma z, we always let z equal a, so that it's just some variable we can plug in numbers. So we're going to say this unknown z that we don't have, we're going to make it equal to a. So all of these z's are now going to be a's. And so we're going to write our answer as ordered pair 4 minus 5a, 1 minus 9a, and then a. And this is how we indicate that there are infinite solutions. So I do want to show you in Octave what it would look like if you were to put in something that has infinite solutions here. So I'll just call it B this time. We got 1, 1, 4, 5, 2, 1, negative 1, 9. And then if you try to do the row reduced echelon form, it is essentially giving you kind of what we got. It's just got opposite signs. But that, did I make a sign error? Because it's like, wait a minute, those signs are opposite from yes, I did make a sign error. Okay, this is why we check our answers. 4 minus 9 is a negative 5. So that is a negative 5 right there. Yeah, very easy to do. Very easy to make a sign error. You know, if you're not paying attention, if you didn't catch it, I make it. And so that's a negative 5 right there. This is why we check our answers. So this is a negative 5. So that is a minus 5z. This becomes a plus. This becomes a plus. So now let's double check our final 1, 0, negative 5, 4, 9, 1. So you can see that the row reduced left it in this form that as soon as it got some diagonal with zeros above it, it just stopped, because you get to a point where you're like, well, if I try to get zeros here, then I start adding numbers in these other places where there's zeros, and it just kind of gets messy. So this is as far as we go. And then from here, you have to create your equations. So you can't just read off your answers because of the fact that it is a system with infinite solutions. And always check your answers because then you'll see, okay, where did I go wrong? Are there any questions? Okay, not at the moment. So I just want to pull up the application assignment just to kind of go over some things to watch out for. Okay, so number 1 says set up a system of linear equations. So I want to see your system of linear equations. And then it says write the system in matrix form. So you need to make sure that you turn that into a matrix. You could either use the augmented matrix form or you can do the AX equals B form, but you do have to write it as a matrix. And then it says you do not have to solve. So don't do extra work you don't have to do. Okay, so you're going to want to show your work here for computing A, B. This is A, this is B. Don't forget to interpret those results. I see a lot of people forget to do that. Interpret means write a sentence telling me what the columns and rows are telling you what they mean. Okay, number 3. So again, it says write a system of linear equations. So first I need to see your system. Then you want to write a matrix equation. So this is specifically the AX equals B form. And then make sure you solve using matrices. I've seen a lot of people don't solve using matrices. You need to use matrices to solve. But this is one of the places where you can, because this is going to be a 3 by 3. It's going to be very lengthy. So you can give me your original matrix. And then if you use row reduced echelon form or reduced echelon form, you're going to indicate that and then give me the answer. Or if you solve using inverses, you need to tell me what your inverse matrix is and then show the work there. So that's the options there. Here again, we have a system. You want to, so it doesn't say to write a system of linear equations, but in order to get the matrix, you need to write your system first. So make sure that you are writing down your system. And then it says to make sure you solve using matrices. So again, I've seen people not solve using matrices. That's the whole point of this assignment, is to use matrices. So make sure that you are solving. This one's easy enough to do by hand with matrices because it's a 2x2. So you might want to do this one by hand, but I would say problem 3, use technology, because it is very prone to making mistakes, and it'll just, make things easier for you. Just make sure you tell me what you started with, the command you typed in, what you ended with. And if you used Octave, you can just take a screenshot and put the Octave here. That would be okay too. But make sure that you're giving me a sentence with your final answers, because it does say find the number of flowers of each type that the florist can use. So a matrix doesn't tell me what your variables are. Like if I go to our 3x3 we had here, if you just give me the final matrix where it says 8, 10, and 6, I don't know, if this was a problem where you're trying to find different flowers, I don't know which flower goes with each number. So you have to make sure that you write your final answer in a sentence so I know which flower goes with each part of the matrix, because the matrix itself doesn't give you any of that information. So just make sure that you are writing your answers in sentences, making sure that you're actually answering the questions here. So since these are all word problems, so you need to be writing words as your final answers. That's how it works. So that's all I really wanted to point out about the application assignment. And if you check your work with Octave, you can go ahead and put that check in the, paste it in or something like that. That works. Any questions about the application assignment? Okay. Well, yeah, if you haven't looked at everything on the application assignment yet, that's fine. If you've already turned it in and you want to make corrections, you are welcome to do that, because I grade the most recent submission that you have. So you can, go ahead and make corrections or whatever as needed and resubmit, because I'm not going to start grading until Wednesday. So you have until then to resubmit. And if you have questions on it, or if you just want to double check something, just let me know. So. All right, well, I'll let you guys go. I will see you guys next week. We'll talk to you in the discussion and everything, and I hope you guys have a great rest of your night. Bye. Good night. You're welcome.